My name is Tim Murkomen, MSc candidate, Delft University, School of Informatics, Department of Computer Science and Software Engineering. And today I'm defending my final thesis, a blockchain-based privacy-preserving model for secure transactions in Internet of Vehicles. Generally, the study utilizes blockchain as a solution to achieve privacy and security within the ecosystem of Internet of Vehicles. This is the developed model. So once entity, which is the vehicle, ready to transact, first things first, it will be registered because we're utilizing a private permission blockchain through Hyperledger Fabric platform, meaning the entity must first of all be required to register the network. So the entity will initiate registration, and once it initiates registration, it will be managed by the TA, which is the trusted authority. This centralized trusted authority will first of all manage the registration and issue a pseudonym to this entity. Once the entity is approved to enter the network, it will be issued into a pseudonym for transactions, meaning that it will now be anonymous. Then thereafter, there is optional endorsement, and this optional endorsement is just a condition that when the entity needs an additional layer of endorsement, it will seek from a nearby roadside unit, the RSU unit verification. The entity will request an optional endorsement, and then thereafter, it will be broadcast to the blockchain network. And in the blockchain network, three key activities happen. So one is the consensus, the second one is the blockchain creation, and finally the ledger update. And in the ledger update, once these are done, three key activities happen. One is the immutability of records. There is also transparency of transactions and also enhanced security, which brings us the key output of the study. The project is available in GitHub. You can see over here. This is the project itself. I pushed to GitHub, and it's available on my GitHub profile. Now, what happens here, once this network is configured very well, we will transact within the network, and we have, so first things first, we will have to bring down any existing network. So we'll use the command network down before we bring up anything in the network. So we will have to kill all anything within the network. And remember, here we have the chaincode, which is the smart contract for this network. So here we will deploy the chaincode itself in this here, which commits and functions all the transactions very well. So once this is done, we've pulled down any existing network, any other image that exists in this project. Now, once this is done, we will create a channel, and we will name it the channel my channel, and we are using CA. That we secure the transactions. So we inform that we're using CA, certified authorities. Bring up the network and create the channel. So the channel has been created, so we wait the channel to join into the network, and once it joins the network, we will have to now commit the smart contract that we've written, the code itself. So we will commit the smart contract, and here the smart contract here, we are deploying the chaincode, which the smart contract in Hyperledger Fabric in this private permission blockchain is called chaincode. This chaincode, the chaincode name, we are calling it blockchain-based privacy IoV, and then the chaincode path, remember it is located in chaincode /BBPST-IoV /chaincode, and then we inform that the chaincode language we're using here is core programming language. So here, this is the chaincode. This is the part I was mentioning about. So we execute that one, and we give it a moment. This will take a bit some time, so we give it a moment. Let's give it a moment. We give it a moment as we wait for this to. Let's just give it a moment. This is the chaincode definition approved by Peer 1. This is the chaincode definition on Peer 2. So once it is approved by National and 2, we will wait and see. So this chaincode has been successful in both the organizations. Remember, in a private permission blockchain, it must first of all be approved to transact within the network. Once this is done, we will now execute the test script. We will test the script for this network, and then later on, once the script, we first of all we package and deploy the chaincode which is there. Then we will give it a moment as these packages will execute. The second, we give it a moment because the chain code is a bit huge and it must successfully package it. Later on, it must be accepted by organization 1 and 2. So once this is accepted in organization 1 and 2, it will later proceed to the other step where it is a pseudonym. Yeah, let's give it a moment. So packaging and deploying chain code, that is okay. So here it is installing in organization 1. So once it's approved in organization 1, it will proceed to organization 2. Once it's approved by organization 2, it will now transact within the network. So where the workflows of the entity of that is the vehicle will now be accepted in each and every step. So let's give it a moment as it installs on organization 1. So remember that I've automated everything here. We're running scripts. Yeah, okay, that one is successful. It has approved by organization 1. Organization 2 is approved. It's approved in organization 2. So chain code commit here. The chain code is being committed. Let's wait if it's successful. Yeah, it's successful. So key pairs here. It's using some message digest is here as being encrypted. So the entity, you see the vehicle registration is successful here. The vehicle registration is successful. Then once the vehicle is executed successfully, the pseudonym insurance. You see one entity here has been registered and this entity has obtained a pseudonym, this one, which is at this point. So meaning you cannot reverse engineer this entity. Then at the here the register and RSU registered success version here, the transaction has been generated successfully. And then endorsement, which is it has been endorsed, and then it is transaction broadcasting to the entity. And then this is done, consensus and block creation, it has been successfully. And then later on it query any transaction, ledger update. So the ledger has been updated successfully.